Hello students. Now let's see few examples based on probabilities. The first question here, it says a two-digit number is chosen at random. What is the probability that the chosen number is a multiple of 7? Alright, what do we want here is that the two-digit number, when we are choosing any two-digit number, we want to find whether our chosen number is a multiple of 7 or not. Yes, for that, what would be our sample space first of all? Sample space, that is the number of possible outcomes. The outcomes that we have is the experiment is two-digit number. So the outcome would be all the two-digit numbers, right? Two-digit numbers, we know that they start from 10, 11, 12, 13 till they end to 99. After 99 we have 100, which is a three-digit number, so that is not considered. So from 10 to 99 we have total 90 numbers. If you can observe, we have total 90 numbers, 90 two-digit numbers, and out of this 90 numbers we want to find out only those numbers who are multiple of 7. Alright. Now, to check the multiple of 7, first of all, let's go to the table of 7. In that way, we can easily get the numbers which are multiple of 7. Starting from the first, 7, 14. The first 7, we cannot take this one. Why? Because 7 is a single digit number. It is not two digit. We want only two digits. So we cannot consider this 7. So we'll start from the next one. 14. Then we have 21, 28, 35, 42, 49, 56, 63, 70. Alright, and after that, what we can do is here, after that you can go on adding 7. So that is 77, 84, 91, 98. After that, if I'm adding 7, I will get a three-digit number. We don't want that. Our restriction is up to two-digit number only, right? So the two-digit numbers which are multiples of 7 are these numbers, and all these numbers together are 13 in numbers. So when we are finding out the probability, the required probability is the total number of favorable outcomes, which is 13. That is those two-digit numbers which are multiple of 7. Alright, divided by the total number of possible outcomes. Possible outcomes is all the two-digit numbers which starts from 10 to 99, and total we have 90 numbers. So that is 13 by 90. So the required probability that a chosen number is a multiple of 7 out of all the two-digit numbers is 13 by 90. Alright, now look into the second example. Two friends, Harish and Kalyan, appeared for an exam. Let A be the event that Harish is selected and B is the event that Kalyan is selected. The probability of A is 2 by 5 and that of probability of B is 3 by 7. Find the probability that both of them are selected. Now here we have two events, right? The first event says that let A be the event that Harish is selected, and for B event we have that Kalyan is selected, that they are appearing for an exam. Both of the probabilities are already given to us. The probability of Harish getting selected is 2 by 5. The probability of Harish getting selected is 2 by 5, whereas the probability of Kalyan getting selected is 3 by 7. This data is given to us already in our question. We are supposed to find out the probability that both of them are selected, which means Harish as well as Kalyan. both of them are selected. Both of them as in Harish is also selected and Kalyan is also selected. Which means when we talk about two events and we want to find out both of the events, and if we have the word and in between both the events, at that time what we have to do, we have to use the multiplication theorem, which means we can multiply their probabilities. We can either multiply their favorable outcomes, or if we have probabilities, let's take out the separate probabilities and multiply them. We already have probabilities given to us, right? So by multiplication theorem, this would be probability of Harish getting selected and Kalyan also getting selected is multiplication of both the probabilities. We already have both the probabilities here, so that is, sorry, this is 3 by 5. We have both the probabilities here, so this would be 6 upon 35, and hence the probability of both of them selecting is 6 by 35. In previous examples also we have seen these type of examples where we have talked about the multiplication theorem as well as addition theorem. When there are two events defined and whenever between the two events there is the word and, in this case we use the multiplication theorem, which means both the events we multiply them together. We find the probabilities, we multiply the probabilities, and when both the events have or word in between them, which means event A or event B, in that case we have to apply the addition theorem. Addition theorem says to add both the probabilities separately and get the answer. Now for the next example, we have a bag containing only red and only red, green and white balls. Yes, a bag contains only red, green and white balls. In one bag I have red, green and white ball. The probability of selecting a red ball is 1 by 3. The probability of selecting the white ball is 1 by 2. If the bag contains 9 green balls, find the total number of balls in the bag. Here we have total 3 balls in the bag, which is red, green and white. Yes. Let's see whatever the data. Here, the data that we have is mixed up, which means probability of some ball is given and total number of some ball is given. And we have to find out the total number of balls in the whole bag, which means total number of red, green and white balls. Now let's see what data we have for each of them. Probability of selecting the red ball. Let's denote it as P of red is given to me as P of red given to me as 1 by 3. Next, probability of selecting a white ball, which means P of W, let us denote it by P of W. This data is given to me as 1 by 2. Next that we have is that bag contains 9 green balls, which means the data, we don't have the probability of green balls. We have only the number of green balls, which is 9. And they have asked us to find out the total number of balls in the bag. Total number of balls in the bag as in the red, green and white ball. Yes. So first of all, what we will do is that into this one, since we don't have the probability of green balls, we have probability of red given to us and probability of white given to us. We don't have the probability of G. So let's first find out that. All right. Now, previously, you must have seen the axioms of probabilities. In axioms of probabilities, we have one axiom which says that probabilities of all events, if we add them together, probabilities, if I have total 3 events, probabilities of all the events, adding them together will always be equal to 1. Total probability would always be equal to 1. Since here also we have 3 events. One is probability of red, green ball and white ball. Addition of all of them together will be equal to 1. Why? In the back, I have only red, green and white balls. There are only 3 events. Yes. So, the axioms of probability says that addition of sum of all the events, probabilities of all the events will always be equal to 1. Here we have 3 events only. That is why the probability of red, probability of green plus probability of W is equal to 1. Now what is probability of red given to as 1 by 3 plus probability of G unknown hai, we have to find this one out, plus probability of half is 1 by 2 which is equal to 1. Now let's solve this one further. Let's keep this probability of G as it is 1 by 3 and 1 by 2. Let's take both of them on the other side of equal to. 1 by 3 when it goes on that side, minus 1 by 3 and this will be minus 1 by 2. After solving them, we get the probability of G as 1 by 6. Probability of G as in probability of the green ball, we have it as 6. Yes. Now, let's see the probability of green ball is equal to 6. Further, what we can do. Probability of green balls is 1 by 6. The formula for calculating probability is, let's substitute onto this side. Number of green balls divided by the total number of balls equal to 1 by 6 as it is. Number of green balls is already given to us in our question, which is 9. So when we substitute into this formula, this would be 9 divided by the total number of balls equal to the probability 1 by 6 as it is. So by solving this one, we can get the total number of balls. Total number of balls. Do the cross multiplication here. So this would be equal to 9 into 6, that is 54, which means the total number of red, green and white balls together in the bag is equal to 54. I hope this is clear with you all, where we don't have to find out the direct probability. There were 3 events and out of them half data was given for each of the event, and from that we have calculated the total number of balls, that is the sample space. Now let's look into this question. There is a bag full of colored balls, red, blue, green and orange. Balls are picked out and replaced. There is a bag in which we have red, then we have blue, we have green and we have orange balls, right? These balls are picked up from that bag and replaced. Yes, replaced as in when the balls are picked up, they are kept again into that bag. If I'm taking them out of the bag, one ball at a time, I'm checking what color it is, I'm keeping it back into the bag. Right? This is what we mean by picked out and replaced. John did this 1,000 times and obtained the following rules. Yes, if John did this 1,000 times, which means in that bag we would have 1,000 balls, right? That is why he had picked out 1,000 times. So my sample space N of S here would be 1,000. And out of this 1,000, we have few results over here, which is the blue balls that are picked up is 300, red balls is 200, green balls is 450 and orange balls is 50. We want to find out the probability of picking a green ball. The probability of picking a green ball would be the total number of green balls divided by total balls. Green balls we have is 450. So 450 divided by the sample space here we have seen was that there were total 1000 balls in the bag. So that is 450 divided by 1000. So after reducing, this would be 0.45. So the probability of picking a green ball here for this one is 0.45.